formulas that we use in order to find these values are, as you can see, you can get, every formula is simple once you understand it, but it's not, it doesn't look very user friendly, correct? So I'm just going to be using Excel as the main way of solving for these problems. I do want to just very quickly go through what's called the equivalent annual rate. EAR or effective rate. Okay, this is because sometimes this really helps understand why the compounding effect is so important. Here is the argument. If I were to tell you that I'll give you 12% return interest compounded once a year. Compounded once a year means that basically you're earning interest. The interest is calculated just once a year. If you invest $1,000 and I give you 12%, then you know that you're going to earn $120, right? Now, you're going to earn $120 because at the end of the first year, you're going to have $1,000 in your account. 12% is calculated and you get $120. All right. Now, what happens if instead of compounding it once a year, I compound it more frequently? How much would you earn? Would you earn more or less? And the intuitive answer is, well, if you compound interest more frequently, if you estimate my interest expenses, my interest benefits more, let's say once a month, then I will be getting additional money every month that itself will start earning interest as well. So it kind of seems intuitive that if you more frequently calculate interest payments, you're going to be better off, right? So the equivalent annual rate, what it does is that it basically lets you find the answer to the question, how much interest am I really earning when I compound things more frequently? And here's the way it goes. Take your nominal rate. Let's suppose in my example, my nominal rate is 12%, right? Then find out how many times a year you're going to be estimating interest. Is it going to be every month? So if you, let's say, are going to be receiving interest payments every month, then the number of compounding periods, the number of times that interest is calculated is going to be 12, right? Every month, there are 12 months in a year. Apply this formula and you'll find out what is the equivalent annual version of you earning 12% but compounded every month. So let's crunch the numbers just to see what this really means, right? So my equivalent annual rate, right, is going to be equal to, if assuming that I'm going to earn 12%, okay, 12%. I'm just following the formula, okay? But this 12% is compounded. Interest is calculated every month, so 12 times a year. How much interest are you earning every period? Well, 12% divided by 12, it's 1%, right? So every month, you're basically earning 1% of your initial investment. All right, if you raise that to the 12th power and then subtract 1, what you will get is 12.68%. What does that mean? That if you earn 12%, but it's compounded once a year, you're going to get 12%. But if you're earning 12% and your bank calculates it every month, then you will get the equivalent of 12.68% a year. In other words, it's better for you, as you can see, to earn 12% compounded more frequently than to earn 12% compounded only once a year. The more frequently your bank compounds the interest, the higher your overall return. Okay, so the equivalent annual rate is just the equivalent annual interest compounded once a year that has the same effect as the conditions that the bank may offer you. Okay, so keeping that in mind, let's just go through a series, two practice problems. Okay, they're very simple in the sense that I just want you to make sure that the mechanics are understood. But remember, we're going to go to Excel very, very quickly. All right. So here's the setup, right? You receive $1,000 savings account, right? Earning 9% compounded annually on your first birthday. So here you are. Let's write a timeline from now, right? On your first birthday, right? So when you're 1 year old, you receive $1,000. Okay. Now you know that the R under these conditions, right? Or interest is 9%. And the question is, how much money will you have when you are 25 years old on your 25th birthday? Okay. And we assume that you're not going to withdraw any money before that, right? So what are we being asked? First of all, what is this? This is the present value, right? Today. What is this? This is your R, right? And the fact that you're told that you received this when you're 1 year old, and then you want to find out how much your money you'll have at the end of by the time you're 25 years old, that tells you how many periods have elapsed, right? Let's just start. This is n equals 0, right? Period 0. What will this be? Period number 24, right? You've gone from 1 year old to 25 years old, right? So the future value formula is just the future value, right? After 24 periods will be simply the $1,000 earning 9%, right? Raised to the 24th, right? That's how much, that's what the answer is. Let's go to Excel very quickly and find out what does that mean. Okay, so let's go to Excel. Same problem in your Excel sheet, right? And you just have to make sure that you provide the inputs, right? So and in this case is 24. What is I? I is 9%, so just click on the 9%, right? Just use the keyboard, okay? The present value is $1,000. Now, in Excel, what usually happens is that anything you invest today, okay, like money that you have put in a savings account, any investment made today is, imagine that in order to invest or deposit the money in an account, you have to basically put your hand in your pocket and retrieve those funds and put it in the account. Therefore, so that Excel understands which money is invested and which money is received, any investment on your part is going to have a negative sign. So put a negative sign in front, okay, $1,000. And what you're wondering is what will I be able to retrieve, after 24 years of leaving that money in there earning 9%. Okay, so what is the future value of this investment? So I'm going to do equal sign and then type in FV. When you type FV, you'll see that the future value formula appears in Excel. Just double click there. Okay, and just to make things clearer, because sometimes this is not as clear, please click on the FX tab here. Okay, right here. Then it says, okay, give me the rate. So you just click on the cell that has the rate. Which of these has the interest rate? Right here, 9%. Notice that the cell reference immediately appears here. It says what number of periods, how much is that? Just click on the cell that contains the number of periods. This is why it's so important to be very structured, okay? Payments occur when in annuities that I explained before, right? When you have payments that that repeat. In this case, in this example, there's nothing like that, so we just leave it empty. For Mac users, sometimes Macs don't like you to leave this empty, so you have to put a 0 there. Okay, it really depends on your machine. For the rest of us, leaving it empty means that it's not going to be used for calculations. What is the present value? The present value is the $1,000. Okay, the type 0 or 1. The default value is 0 or empty, which means that these are end of period cash flows. Most cash flows that we're going to be talking about will be end of period cash flows. But if were ever the case where there are beginning of period cash flows, then you would type in a 1. But generally we leave this empty. Press OK. And so the answer is 7,911. That's how much you'll have at the end of the 24 years if you only put $1,000 and leave it there for earning 9%. Okay, it's important that you earn interest over interest, but it's also important that every year you put more money, right? That's what savings is about. But for now, if you don't do anything, that's what you'll have at the end of 24 periods. Okay, let's go very quickly to the second problem just to show you what the second type of question will look like. You're offered $100,000 payment in 8 years. Okay, so here you are, basically knowing that 8 years from now you will receive $100,000, right? So in 8 years, what is this then? This is the future value, right? Future value in year 8. 8 years tells you the number of periods, which is n. If the interest rate is 10% compounded annually, right? This is your R. The question is, what is this payment worth to you today? So what is the unknown? The unknown is what is the value today, right? So the R is known, 10%. This is the future value, and what you don't know is what are these $100,000 worth to you today? How much would you be willing to pay for the right to receive $100,000 8 years from now? Okay, and the formula, you may remember, this is the last time we're going to use the formula. It's just the future value, right? In this case, at the end of year 8, discounted, right? It's brought back to 0, right? By discounting, dividing it by 1 plus your interest rate, which is 10%. How many periods are we discounting? We're just discounting these 8 periods. Okay, so this is what the answer should look like in Excel. Let's keep this in Excel. That would mean the following. Okay, the future value. Remember now, you're offered $100,000, right? So these $100,000 are something that you will be receiving. So I'm going to type in 100,000. Okay. The number of periods is 8. The I is 10%. I'm just typing these. And the unknown now is not future value, but rather present value. So I do equal sign, PV, and there it is. There's only one function. There's the PV function, present value function. As before, press FX. And what is the rate? The rate is 10%. What are the number of periods? 8. Payments are not important at this point. The future value is $100,000. Type is left empty, and you press OK. And the value is 46,650. Why is it in red? Because all Excel is saying is that, oh, if you're going to receive $100,000 for this investment, then that means that you would have to be willing to pay $46,000 for this investment. So the red just means that this is something that you would have to pay in order to receive $100,000. It's just the way Excel works. It doesn't mean that you're losing money. It's just the way Excel needs to think. Okay, so receiving $100,000 at year 8 is the same thing as receiving $46,000 today. This is the present value of those $100,000.